Okay, so we've discussed that in its most basic form, all algebra is creating sets of symbols and then defining composition laws on those sets of symbols. Now, obviously there are a huge number of potential composition laws you can produce, and most of them are not going to be very interesting at all. Now, groups are basically composition laws which obey a bunch of nice properties that make it possible to solve equations within them. Okay, so I'm now going to show you an example of a group composition law that we could produce with these same three symbols, but this time it's going to obey these three axioms that I've given you, which are that it needs to obey inverses. Okay, so it needs to have an inverse for every element, it needs to have an identity element, and it needs to obey associativity. Okay, so let's put them all in this composition table again. Okay, and by the way, one of these composition tables like this is also what's known as a Cayley table. They're also named after the famous mathematician Cayley. So they're called Cayley tables. Right, and then backwards 5 we'll have here. Okay, so we're making a very simple little group here, and in fact there's actually only one group that we can make of size 3. So I haven't really got that many choices of what I'm going to actually do here. Right, so let's start by making one of these our identity elements. So remember, the first axiom of group theory is that you need to have an identity. Okay, so you need to have an element which composes with all other elements in both directions to give that other element back again. So let's make it sand timer. Okay, so here's sand timer. Sand timer composed with any other element needs to equal that element back again. So sand timer composed with sand timer needs to equal sand timer. Okay, because we're now plugging in sand timer as x here, and therefore it has to give itself back again. Sand timer composed with backwards 4 has to give backwards 4. And sand timer composed with backwards 5 has to give backwards 5. Now that's not the only thing that has to be true. It also has to be true that x composed with backwards timer, x composed with timer is equal to x again. So it has to be true that if you compose on the right with any other element, then it has to give that element back again. And if you compose on the left with any other element, it has to give that element back again. So here are all the variables here now. So sand timer composed with sand timer we've already got. That should need to equal sand timer. Then for backwards 4 composed with sand timer, we're putting backwards 4 in here now, should also equal backwards 4. Okay, backwards 5 composed with sand timer should also equal backwards 5. Okay, right. So that gives us an identity element now. So we have our identity element.